As you're going to compare titanium containing rutile and ilmenite, whatever that is, FeTiO3, by showing which mineral has the larger percentage of titanium. Okay, it says you should be able to figure it out without calculation, but we're going to use the equation to prove this and prove which one has higher percentage of titanium in it. Okay, so it's like you could think about it this way. So you could figure out the mass of titanium only out of mass of the whole thing for each. Okay, and then we could figure out what percentage of titanium is in the whole thing. So let's first talk about the rutile. Okay, so let me get P table. Okay, here's P table, periodic table. We have titanium molar mass. It will be 47.867 grams of titanium out of, so we're doing the rutile. Let me get the formula, TiO2. Okay, out of the whole, so we got to figure out the whole molar mass for the whole rutile, TiO2. So that's titanium plus 2 of the oxygen. I'm just going to round it to 16. Like that. Okay. Well, so that's going to be 47.867 over, let me use my calculator here. It's 79.867. So when you divide those two numbers, you're gonna get 0.5999, something like that. 5993 and on, but it's percentage, so you got to multiply by 100%, so it's going to be 59.9%. Okay, so I'm going to write 59.9%, and we're going to do the same thing with the other one. So this time we want to figure out again titanium mass out of the whole thing. So whole thing should change now. Just that part, okay? Because it's still titanium, I'm going to leave everything else same. This time I'm going to use green color. So that's titanium, 47.867 plus, I'm sorry, you have iron there too. So that's I'm going to add 55.845. That's iron, and then titanium's at 47-ish, and then I'm going to add 3 times of the oxygen because you got 3 of them. So that's FeTiO3. Let's see what that comes out to be. That comes out to be 151.712. So I need to divide now. That's 30. If I multiply by 100%, that's 31.55, so 6%. Then, which one has more titanium? The rutile. This guy has more titanium in it. Okay, and you could figure out by knowing the whole molar mass, because for the other one that we just did, FeTiO3, the denominator gets really big. Okay, so percentage will go down. Okay, this problem is asking for molecular formula of a compound. It's unknown compound that contains C and H. So C, some kind of subscript, H, some kind of subscript. So this is a whole molecule that we don't know the formula of. But we do know that there's 46.1 grams of carbon in it, and then 3.8 grams of hydrogen in it. Okay, and we have to figure out what the molecular formula is, given that the molecular mass is 78.12 grams per mole. Okay, you could try this by yourself. You could pause the video. Okay, now the subscript here is sort of like a molar ratio. So if you have like C1 and then 4 H's, that means for every 1 mole of carbon, you're gonna have 4 moles of hydrogen, like number-wise. So the values that they gave us are in grams. They have you got to change it to number-wise, like quantity-wise. So you gotta first convert both of them into their moles. Okay, so we know that carbon, there's 12 just going to use 12, okay, 12 grams in 1 mole, and hydrogen, 1.01, or yeah, I'll just use 1.01 grams per mole. Okay, so if you have 1 mole of hydrogen that has that's going to weigh that's going to have 1.01 grams in mass. If you have 1 mole of carbon, it's going to have 12 grams in mass. So we're going to use molar mass to convert these grams. So we're going to use molar mass to convert these grams into moles. So we got 12 grams of carbon. To cancel out grams of carbon, we have 1 mole of carbon. Okay, so that unit cancels. You have 1.01 gram of hydrogen. That's 1 mole of hydrogen. Okay, so let's figure out what their moles are. So I'm going to use my calculator and divide. That's about 3.84. I'm going to use 1 more decimal, so 2. That's about 3.84. I'm going to use 1 more decimal, so 2. So 3.76. 1 more decimal, 2 mole of hydrogen. Okay, they're pretty much about the same, but hydrogen has a little bit less mole. So what you want to do is now divide everything by the which one's less. So like divided by 3.7262. So we have so this will be 1. So we could know the relative amount of carbon, okay, relative to the number of moles for hydrogen. So that's 1.02. So you see how it's really close to each other? Then it should be 1 to 1. Okay, 1 to 1 ratio. But you're not gonna see, this is the empirical formula. Okay, you're not gonna see like a carbon attached with only 1 hydrogen. So now what you want to do is, we know that it's 1 to 1. We don't know whether it's gonna be C4H4 or something like that. So now what you need to do is, so you need to figure out the mass for these. So we have 12 for 1 carbon, and then 1 for hydrogen. That's going to be, I'm just going to use 1.01 again. 13.01, okay, grams. So now I need to figure out how many grams can fit into 78.12. So what I'm going to do is 78.12 divided by 13.01 to see how many factors there are. There's about 6 much. So what you want to do is you put 6's in each. So it's going to be C6H6. That equates to have a molar mass of 78.12 and still maintains that 1 to 1 ratio. So this will be your molecular formula, C6H6.